Swayam Prabha. Digital India. Educated India.
Namaste and welcome back to the video course on watershed management. In module number 7 on management of water quality, in lecture number 30, today we will discuss about the environmental guidelines for water quality management. So, some of the important topics covered in this lecture includes water quality management, monitoring, water quality guidelines and steps in water quality management. So, the key words for today's lecture: water quality management and environmental guidelines. So, as we discussed earlier, so this water quality management is a main say we have to deal with most of the time say watershed based water quality management. So, it is one of the important issue which we have to deal in water related issues like water resource management or water say watershed based say water resource management etc. So, it is not only the quantity of the water, but quality of the water is also important. So, that is what we are discussing in the last few lectures. So, as we discussed say for surface water or groundwater, there are various sources of pollution like say groundwater or say surface water, the pollution sources can be different, and then we will be discussing about how we can control this pollution and then wherever polluted how we can remediate. So, that is what we were discussing in the last few lectures. So, now as far as water quality management is concerned, as we discussed in one of the earlier lectures. So, we need a very strict guidelines, so that we can go according to that guidelines. So, first of all the guideline means say as far as the water quality is concerned, what are the parameter values say which we can go maximum or minimum, and what are the other things as far as the parameters are concerned. So, that is one thing, and then what frequently what say the frequency of taking the samples. So, that we should know we have to constantly monitor say whether it is surface water or groundwater, whether the quality is maintaining or not. So, that way we have to see, and then what are the methodologies which we can adopt to keep this water quality management. So, that way we need say guidelines as far as the water quality management is concerned. So, water quality management is for a great deal controlled by authorization of discharges of dangerous substances, for which monitoring of discharges, effluents and influenced by surface or groundwater is essential. So, say if you consider surface water say like river water or lake water, or if you consider groundwater, then we have to see that as far as the say if we once we say put certain say measures, say I mean the guidelines say like this much should be the quality or say various parameters, the maximum limit or minimum limit once we specify say, and then this say we have to strictly follow this through certain guidelines. And then say authorities say we have to strictly monitor this what way it is going, whether the pollution is taking place or whether pollution is reduced or whatever way. So, we have to see that some like state pollution control board authorities or central pollution control board authorities. So, like that various authorization agencies should look into the quality issues or the pollution problems. So, that way when we look into water quality management and water quality management guidelines, so there can be the guidelines related to national level, like say for example, India Central Pollution Control Board is there, which is the authorized agency to look into the various water quality management issues and then its guidelines formulations. And similarly, we can have also state level. So, various states say we can have various policies and then regulations as far as the water quality management is concerned. So, then say presently, say as we can see presently, the quality and availability of the fresh water resource is most pressing of the many environmental challenges, say for example, national horizons. If you consider say India or either any country is concerned, say the quality of the fresh water, whatever we are getting, so that is the availability as well as the quality is the main issue. So now as the population is increasing, say like geometric increase in population coupled with the rapid urbanization, industrialization and agriculture development, this has resulted in high impact on quality and quantity of water. So as we discussed in some of the previous lectures, quantity is a main issue, so whether sufficient quantity of water is available, say for example for domestic, industrial, agriculture or the recreational purposes, and then say for each purposes or each uses, as we have seen earlier, there are certain norms as far as the various parameters are concerned, say the maximum limit or minimum limit. So the quality that way is a main issue, especially say in a country like India where the population is exploding, and then number of new cities are coming and rapid urbanization is taking place. So that way there should be national benchmarks to assess the potential or actual impairment of socially relevant resource uses, such as water resource, say it's the quantity of the water and the quality of the water. So there should be national benchmark. So that way we can see that the Bureau of Indian Standards has come up with certain guidelines as far as the water quality management is concerned, and then say the various parameters, say whatever the say for drinking or other purpose, how we should have. So that way there should be as far as say total water quality management is concerned, we have to see the norms are available and these norms are strictly followed as far as the management is concerned. So there should be scientific basis for the development of site specific criteria, so that these criteria are called guidelines, and then objectives or standards indicators. So as we have seen, certain indicators or standards should be there to achieve the quality of the water, say for example drinking water standards or any other for any other use. So scientific tools for assessing risk, say like with existing concentration of persistent or bioaccumulative and toxic substances in the ambient environment. So as far as environment is concerned, whether it is air, water or soil, so we have to come up with certain tools to assess the risk. Say for example, we have to monitor the various parameters, say as far as water quality is concerned, and then there should be scientific tools to assess whether we are meeting the said guidelines. So that way a number of issues are there as far as water quality management is concerned. When we deal with the water quality management, so say generally we call it as environmental water quality. So environmental water quality means the ambient water quality relates to water bodies such as lakes, rivers, or oceans or aquifers. Say we say that the water quality which is very much related to the environment, whether it is say the aquatic body like lakes, rivers, ocean, or whether it is the groundwater systems. So we have to see that the ambient water quality and its environmental values or particular values are met. So parameters for water quality, say as we discussed earlier, this depends on the intended use. So as we have seen earlier, say for example, if you are using water for drinking purpose, then that the guidelines which we will be setting for various parameters will be different than say for example if we are using for agricultural purposes. So water quality standards we have to mention depending upon the intended use. So water quality standards, these are focused on water treated for human consumption or industrial use or for the environment like ecological needs. So we have to see the standards as far as water quality standards are concerned, whether it is human consumption or industrial use or say ecological needs. Say we have to see say water, first of all we have to set the standards, and then we have to continuously monitor and then see that the standards are met for the particular water say which we are utilizing for the particular purpose. So water quality standards, say we can see that there will be standards for surface water or groundwater, and this may vary significantly due to different conditions or uses. Say for example, surface water generally we take from the rivers, lakes or reservoirs, but in groundwater we are pumping out from the aquifer system. So, that way the standards say slightly vary, say depending upon the use or depending upon the say the extraction of the water is concerned. Say for example, the hardness of the water, say industrial purpose, if say we have to see the hardness of the water, then the groundwater is concerned when we are pumping, then the hardness may be higher depending upon the location from which we are pumping. So, that way the water quality standards may change whether according to surface water or groundwater. So, then say also like say for example, the toxic substances and microorganisms say which is a health hazard for non drinking purposes such as irrigation, swimming or fishing, rafting, boating and industrial use. So, this will be say all these things, the standards will be different depending upon the intended use, and then whether it is depending upon the source also, like surface water or groundwater, it will be varying. So, then say if you consider the modern water quality laws. So, these modern water quality laws specify the protection of water resource depending upon use, as we have seen. Whether it is groundwater, there may be certain specific norms as far as the protection is concerned, or if it is surface water, there may be some other specific norms. So, like say for example, say depending upon the use as a minimum or retention of current quality standards. So, like that there will be variations as far as the water quality laws or its management is concerned. So, then as we were discussing, so as far as water quality is concerned, we should have certain guidelines, and then when we are preparing these guidelines, say we have to first say depending upon our objectives, we have to set the goals, and then we have to see the specific guidelines to achieve these goals. So, let us look what are the important goals as far as water quality guidelines are concerned. So, these are given in the slides. So, science based goals, say like different kinds of goals can be there, say science based goals or performance indicators, say for example, regional, national or international management strategies for toxic substances. So, if we consider specific type of toxic substance, we have to see, so these standards or the guidelines may vary for the particular region or particular nation, or say international standards may be varying depending upon say what kind of use, or say for example, the American standards will be different from European standards, or it will be different from Indian standards. Then interim management objectives, say for persistent bioaccumulative and toxic substance to track progress towards their virtual elimination. Say for example, say some specific toxic substances we have to virtually eliminate, or the bioaccumulative or bioorganism we have to eliminate from the particular water which we are using. So, accordingly we have to set the goals. And then indicators of ecotoxicology, like relevant concentrations of persistent or bioaccumulative or toxic substances for the purpose of improving analytical detection and quantification capabilities are needed when we set the specific goals as far as the water quality guidelines are concerned. So, accordingly we should have the tools to evaluate the effectiveness of say point source controls, or the non-point sources controls are concerned. So, as we discussed, the pollutant source can be point source or non-point pollutant sources. So, the point sources we can easily identify, and then we can evaluate it, and then we can try to control it. So, that way we can set our water quality guidelines depending upon say from where the pollutant source can come, whether it is point source or it is non-point source. Accordingly we can set our goals, and then that way there should be a scientific basis for environmental regulations and benchmarks or targets in the assessment and remediation. So, when we deal with water quality management, we should have specified environmental regulations or rules or laws, and then we should have the benchmarks, say to say that okay, this should be the particular limit of particular substances in a water, in the water which is for specified use, or the, say for example, the wastewater coming from industrial source or the municipal source. So, that should meet certain criteria, certain guidelines or certain standards before it is say put into the rivers or lakes or to the ocean. So, that way there should be certain benchmarks or targets say as far as the water quality management issues are concerned, and this can be either for assessment or it can be for remediation also. So, now let us look into various issues related to water quality guidelines. So, water quality guidelines, actually as we discussed, this guideline shows values for indicators and are designed to ensure that various environmental values of waters are protected. Say for example, if we consider say the in particular water for drinking or other purpose, say arsenic limit or fluoride limit, or the total dissolved solids limit or BOD limit or COD limit, like that we have to specify the indicators, and then accordingly the environmental values to be specified, and we have to ensure that these are met for the particular samples which we will be doing as the water quality monitoring is concerned. So, there will be, as far as the environmental values are concerned, main nationally recognized environmental values for waters are, say for example, ecosystem values. So, the water which we are using for ecological needs or ecological water use. So, for that the certain specified environmental values we can prescribe, and then ecosystem protection, say like say we can come up with guidelines as far as the aquatic plants are concerned, or fishing is concerned, or say the habitat or the ecosystems or the maintenance of the rivers and lakes are concerned. We can come with a certain the guidelines with respect to the environmental values, specified environmental values are concerned. And then human use values, like for say for example, water usage for agricultural or recreational use. So, accordingly we can put the specific guidelines, and then of course, say some of the stringent guidelines will be for drinking water supply. So, we should meet specified say quality requirement as far as the drinking water usage is concerned. And then say it can be for even for cultural values, say for example, say for religious purpose, when we are using say some location of the river or some lakes. So, then we have to specify say what are the water quality guidelines, say for the particular use or particular say when we do monitoring or when we do sampling, what should be the guidelines. So, now each of these environmental values requires its own specific set of guidelines, because the acceptable guidelines say or guideline values to maintain one type of environmental values may not be acceptable to maintain another environmental values. So, these environmental values what we discussed that depends upon the particular usage or particular source, like as we discussed. Say for example, say if you consider pesticides levels, say in the aquatic system, say these pesticide levels required to protect the fish and other fauna are usually lower than those required for protection of irrigated crops. Say the pesticides which we are putting say to protect the crops itself. So, for that the limits for the crops or for the irrigation issues are concerned, that will be different than what we consider the pesticides levels, say when we deal with the fish habitats or say other flora and fauna concerns. So, now another reason is that the indicators used to assess one environmental values may be different to those used for other environmental values. So, say the environmental values, say depending upon the source of the water, and then the usage, these environmental values vary. Say for example, a key indicator for recreational use is fecal bacteria numbers, but this indicator is not used for most other environmental values like agricultural purposes or ecological needs. So, like that the water quality guidelines, it will vary or the environmental values which we have to specify, that also varies. So, as far as water quality guidelines are concerned, say we have to come up with say the rules and regulations or laws. So, we have to come up with documents as far as the various say usage or various sectors are concerned, and then this should be authorized by, it should be from authorized agencies like pollution control boards or other government agencies, so that can be strictly implemented as far as the various environmental values or various guidelines are concerned. So, it can be for ecosystem protection, or say for example recreational use, say for example guidelines for managing risk in recreational waters. So, say for example if for say swimming purpose, or is it is for boating purpose. So, what kind of recreational use water is used, so accordingly we can come up with certain values or guidelines as far as the environmental values are concerned. Then human consumptions like national standards. So, of course, as we discussed, say Bureau of Indian Standards or European standards, or like that various national standards are available, say Australia, New Zealand food standards code, etc. So, there accordingly we can set our guidelines. Then drinking water supply, say for example Indian drinking water guidelines, we can come up with specified guidelines, and then we can see that these guidelines are met or not. And then as far as cultural values are concerned also, if it is required, we can come up with specified guidelines, but generally this we have to see that the water quality is met with respect to certain standards, but strict regulations are not set as far as the cultural values are concerned. So, now let us look into various steps in water quality management. So, while setting the water quality management guidelines or the environmental guidelines, so we have to go in a systematic way, step by step procedure should be adopted, so that we will be meeting the same the international standards or international guidelines, say as far as the water quality is concerned. So, and then also say we have to start with, we have to first come up with a plan how to develop such guidelines or the say to meet this water quality management issues. So, we may have to interact with the various stakeholders, or we have to do lot of field survey, and then frame these laws and then put into the public the water quality management guidelines or environmental guidelines, and then take their opinion also, other than the of course from the experts, we have to take the opinion, and then finally we have to come up with the guidelines as far as the water quality management is concerned, and that should be publicized, and then we have to see that these guidelines are met by various stakeholders like industries or the public are concerned. So, that way we have to go through a step by step procedure as far as the water quality management issues are concerned. So, here say as per the Central Pollution Control Board, Government of India, as given in this website. So, they have come up with about 11 steps as far as the water quality management is concerned. So, it starts from say step number 1, setting water quality goal. and then step number 2, water quality monitoring, and then step number 3, identification of nature and magnitude of pollution. Then next one is source inventory, and step number 5, water quantity information, say what kind of what is the quantity of available water and what type of water, whether it is surface water, groundwater, or where is the source of this. Then step number 6, selection of technology. Step number 7, financing waste management. Step number 8, maintenance of sewage treatment plants. Step number 9, pollution from industrial sources. Step number 10, pollution from non-point sources, and finally some other important options for water quality management. So, generally say when we are setting the guidelines for water quality management, we have to come up with a document, and then once the document is prepared, so to assure this water quality the issues are or water quality control measures are met, we have to say go through a systematic procedure. So, as given by the Central Pollution Control Board, Government of India. So, these are some of the 11 steps which we have to follow as far as the water quality management is concerned. So, now we will discuss each of these steps in detail, so that we can understand say how each steps are important and what are the important things we have to look when we look into the water quality management issues are concerned. So, this is actually specifically made by Central Pollution Control Board, Government of India, and for other countries also there may be these kinds of guidelines as far as the water quality management issues are concerned. So, first let us look into step number 1. So, step number 1 is mainly setting the water quality goals. As we discussed say before going for any kind of activities related to water quality management, we have to set the goals. So, these goals we can derive based upon the international standards like World Health Organizations or FAO norms or various norms. So, we can say study all these things, and then what are the depending upon the sources of water for specified usage, or what kind of according to what kind of intended use. So, we can set our goals. So, once the water quality goals are set, we have to see those goals we are meeting for specified uses. So, now let us look say what are the important water quality goals which we have to set. First one is identification of uses of water in the given say water body. So, say like say for example, river or lake is concerned, say what are the say specified uses as far as the water is concerned, whether it is used for irrigation purpose or it is used for the drinking purpose or industrial uses like that. And then the term quality therefore must be considered relative to the proposed use of water. So, as we have seen, say each usage has got its own say specified norms are there. So, according to those norms we have to see that we have to consider the quality as far as when we set the water quality goals. Water quality say as we discussed earlier is defined as those physical, chemical or biological characteristics of water by which the user evaluates the acceptability of water. So, depending upon whether it is for drinking purpose or whether it is irrigation purpose or for industrial purpose, say we will be setting certain goals or certain norms or certain criteria, and then accordingly whether we are meeting those specified criteria, so the user can evaluate. So, that way the setting of the water quality goals are very important. So, each water use has specific water quality needs. So, as we already discussed earlier. So, say for example, designated best use means out of several uses a particular water body is put to the use which demands highest quality of water is called its designated best use. Say for example, if you consider the water in a reservoir. So, the designated best use, so the water in the from the reservoir may be used for drinking purpose, may be used for irrigation purpose, may be used for recreational purposes. So, out of this say for example, the water quality goals are concerned, maybe most the most important goals will be as far as the drinking water purposes. So, that way the highest quality of the water is say what is needed is for drinking purpose. So, that norms we will be keeping, and that is the designated best use as far as the water in the reservoir is concerned. So, as we discussed earlier, say according to Central Pollution Control Board, Government of India, based upon the use, various classifications have been done. So, this we have already discussed earlier. So, accordingly 5 classes of water we can define: A, B, C, D, E. So, the designated best use, say for example, drinking water source, which is class A, the criteria can be the total coliform organisms. So, this should be 100 ml or so say per 100 ml shall be 50 or less. Then pH should be between 6.5 to 8.5, dissolved oxygen should be 6 milligram per liter or more. BOD should be 5 days 20 degree centigrade should be less than 2 milligram per liter. So, like that, say this is for drinking water use and class A water as per Central Pollution Control Board norms. Then class B is outdoor bathing. So, here say the criteria related to total coliform organisms say should be less than 500 per 100 ml water, and pH is same 6.5 to 8.5, and dissolved oxygen should be say 5 milligram per liter or more, and BOD should be 3 milligram per liter or less. So, this is for class B, which is for outdoor bathing. Then class C is for drinking water source after conventional treatment and disinfection. So, the water which is taken from here will be going through a treatment process, and then it will be also disinfection also will be done. So, there the say as far as the source is concerned, the total coliform say organisms per 100 ml shall be say for example 5000 or less, and pH can be 6 to 9, dissolved oxygen 4 milligram per liter or more, and BOD 3 milligram per liter or less. So, but here this water as shown here, this water will be going through conventional treatment and disinfection. So, that way say the whatever the requirement will be met. But in the class A, it is say only disinfection is done, but no other treatment is done. And then class D, it is for propagation of wildlife and fisheries. So, there the pH can be between 6.25 to 8.5, dissolved oxygen should be 4 milligram per liter or more. Then like free ammonia is concerned 1.2 milligram liter or less, like that various norms can be there. And then the last one is class E, where water for irrigation or industrial cooling or controlled waste disposal. There again pH, electrical conductivity, pH can be same range, electrical conductivity can be up to maximum 2250, and then sodium absorption ratio maximum 26, like that. So, like that we can say based upon the class of water, or based upon the source, or based upon the intended use, we can set the criteria, and that will say accordingly the water quality goals in the first step we can set, and that will be the deciding criteria later stage to see that whether these quality goals are met or not met. So, then that is about the first step. First step was on setting water quality goals, and now second one is say water quality monitoring. So, once we set the goals, so as we discussed in the step number 1, so now say various sources like surface water sources like rivers, lakes or reservoirs or the groundwater aquifers, we have to continuously monitor for the water quality, and then see that say for the intended use the quality is meeting that particular goals or particular values. So, that we have to see. So, that way step number 2 is also very important. So, for acquiring information on existing water quality, So, what is the present stage? So, we have to go for sampling and then we have to see whether the particular samples are meeting the criteria. So, main objectives for water quality monitoring can be monitoring for establishing baseline water quality. So, certain minimum baseline we can keep and then we can see whether that we are meeting. Then observing trends in water quality changes, say from one season to another season, say from summer to monsoon season or monsoon to say spring season or winter season, how the parameters are changing. So, that way observing the trends, and then calculation of flux of water constituents of interest, then a surveillance for irrigation use, then control and management of water pollution, say groundwater only, say as far as the if any pollutant source is there, how we can control it and then how we can go for remediation. So, like that we have to do the water quality monitoring and we have to get the information. So, water quality monitoring is concerned also there are certain specified protocols have been specified by various agencies like in India Central Pollution Control Board. So, we have to see that these protocols are met when we are taking samples and then when we are measuring it and then try to say put into as far as the set goals are concerned. Then design approach and delineation of actions necessary to operationalize the monitoring program. So, we should have network of collection of the samples and then monitoring it continuously, say specified days or specified periods, and then this data should be available. So, ready reference for the field staff should be there, field staff or laboratory personnel should be or managers should be there as far as monitoring programs are concerned. So, we have to set guidelines, we have to set the norms for water quality monitoring, and that norms the field personnel or the laboratory person who say field person collect the samples and laboratory persons test these samples and the managers are controlling all those things. So, that way ready reference should be available as far as the various norms or various guidelines as far as water quality monitoring is concerned. So, as far as water quality monitoring is concerned, the various steps are so we have to see the frequency of monitoring and then what are the important parameters to be considered as far as the monitoring is concerned, and then we have to specify the sample collection procedure and then how to keep the samples and then how to take into lab and then how to analyze the samples and then how we can record it appropriately. So, that this will be available as guidelines and that the field staff or the laboratory personnel or the managers will be say controlling the things according to the set guidelines as far as water quality monitoring is concerned. So, now as far as monitoring is concerned, there are certain specified protocols related to the frequency, say how many times in a week or in a day or in a season we have to collect the samples, and then what are the important parameters we have to test. So, accordingly specified monitoring protocols are available. So, let us look into some of these important protocols as specified by Central Pollution Control Board. Say for example, if groundwater is concerned, initially all stations will be classified as baseline stations. So, as far as groundwater is concerned, we may select we may collect the samples from dug well or bore well or very deep tube wells, and then initially we keep these stations as baseline stations, and about 20 to 25% of these baseline stations will also be classified as trend or trend cum surveillance stations. So, in about 1/4 of this baseline station, we very frequently or we take the samples and monitor in a very systematic way, and so that we can identify how is the trend as far as the water quality is concerned. So, this can with these stations we can call it as trend cum surveillance stations. Then say after a few years, say for example 3 years as specified by Central Pollution Control Board, say these stations we can reclassify and then maybe some other stations can be chosen, say as far as whether it is as a baseline station or surveillance stations are concerned. Now, as far as surface water is concerned, to start with, all stations will be combinations of baseline and trend stations. So, as far as the wherever we take the samples, say we can classify as either baseline stations or the trend stations. So, we can have a combinations of this baseline and trend stations, and then samples will be collected say at least every 2 months, say like say in India during May, June, or then August, October, December, February, April, like that. So, this is according to the seasonal variation, like monsoon season, or this is May, June, say summer season, then monsoon season, then spring season, autumn season, like that. So, the samples will be collected. This will generate at least 6 samples from, say for example, rivers are concerned, perennial rivers, and 3-4 samples from seasonal rivers every year. So, accordingly, when we collect the samples and then monitoring, so we get large number of samples, and then say we will get the data in a systematic way from these either baseline stations or the trend stations. Then after the data collected for, say for example, 3 years, the station will be classified either as baseline or trend or flux stations. So, according to the guidelines specified by Central Pollution Control Board. So, we can say for surface water or groundwater is concerned, we can have the baseline stations or the trend cum surveillance stations, and then this can be say can vary, say we can rotate between those stations, say for particular area, particular zones or particular region is concerned, we can have that kind of flexibility. So, that way we have to strictly follow the water quality monitoring protocol, and then so also we have to see this frequency, say how frequently we are collecting the samples and analyzing, and then what kind of parameters we will be looking. So, that definitely depends upon what the intended use. Say for example, it is for drinking water purpose, there will be the parameters will be, number of parameters will be more and the frequency should be more, but say for example irrigation or say recreational purpose, the frequency can be less, like that. So, now say for example, the various parameters, say for example, groundwater, if you are collecting groundwater for various uses, say for example, the type of stations can be baseline or trend cum surveillance, and then frequency can be for baseline, it can be once every year or pre-monsoon, say mainly between May and June, and various parameters like temperature, water conductivity, pH, etc. we can look into. Then trend, say generally it can be 4 times every year, pre-monsoon, May, June, and after intervals of 3 months. So, all these parameters, some of the important parameters which we will be checking or monitoring. Then trend cum surveillance stations, here minimum 4 times a year we have to collect the data, and then we have to analyze for various important parameters like fluoride, iron, industrial mining or salinity, etc. And these are some of the important parameters like iron content, arsenic, say cadmium, say mercury, etc., and total and fecal coliforms, etc. So, that way depending upon whether it is surface water or groundwater, we can identify the type of stations and then frequency and the parameters. So, that was about for the groundwater. Now, say in this slide, say if you consider the parameters analysis for surface water. So, surface water, say here again the parameters are grouped, then initially the various parameters, then baseline or trend. So, generally what we do for temperature, electrical conductivity, pH, dissolved oxygen, total dissolved solids for all. Then nutrients are concerned various initially or baseline, trend. And organic matter is concerned, say initially we have to check BOD, COD, then again trend is concerned BOD, COD. So, then major ions, other inorganics are concerned, how to deal, then microbiological parameters are concerned like total coliforms or total and fecal coliforms, how to deal. So like that, then biological are concerned generally, say none of these things are considered, since we assume that these biological things, things are not there for the particular water we consider, say, for the intended use. So now, as far as this step is concerned, the water quality monitoring is concerned, another important issue is that how to say take the samples. So sample collection is one of the important issue, so that we have to collect these samples appropriately, store it appropriately, and then send to the laboratories for various testing purposes, so that we will get the appropriate results through which we can make sure that the guidelines are met or not. So now the sample collections are concerned, say reaching sample site using location maps. So particular locations, say specified by the state control board, pollution control board, or central pollution control board, how to reach those sampling sites, so that will be available. Then we can use specified sampling bottles depending upon the intended say water quality which we are going to check. So first we rinse the sample container 3 times with the sample before it is filled. Then leave a small air space in the bottle to allow mixing of sample at the time of analysis. Then the sample code and sampling data should be clearly marked on the sample container or the tag, so that everything will be met properly, so that say the particular say we identify the site location through specified codes and date, like that. Then samples for groundwater, say for example, would be collected from, say, open dug wells or tube wells in use for domestic or irrigation purposes. Then the samples will be collected from well mixed section of the river, say for example main stream are concerned 30 centimeter below the water surface, using a weighted bottle or dissolved oxygen sampler. Then samples from the reservoir sites will be collected from the outgoing canal or power channel or water intake structure. So like that, there will be say specified environmental guidelines, or guidelines will be there for sample collections. So frequency of the sampling, and then the analysis are concerned. So all those things we have to meet in this step number 2. Now the step number 3 is identification of nature and magnitude of pollution. So here, after repeated observations of water quality covering different seasons, the water quality data should be compiled and compared with the desired quality requirement as per the water quality goals set in step number 1. So here say we have to do the testing and then see that whether water quality criteria are met. So this way the polluted water body can be easily identified. So where is the particular location, say surface water, groundwater is concerned, where it is polluted. Then this comparison would lead to identification of the gaps with respect to one or more parameters, and also extent of gap, which will ultimately help in identification of nature and magnitude of pollution control needed. So that is the identification of nature and magnitude of pollution, step number 3 is concerned. Now step number 4 is related to the source inventory. So once the nature and magnitude of pollution is identified, the sources of such a pollution are identified. Then in inventory we have to make an inventory of the number of outfalls joining the water body for identification of point sources. So from where this pollution is coming, how the movement is taking place. So all this we have to identify. So source inventory should be there. So measure the quality and quantity of wastewater flowing through each of these outfalls, and then for each outfall pollution load joining per unit time should be measured in terms of important pollutants. So this exercise requires continuous sampling, say for example 24 hours or 48 hours or 72 hours, like 1 day, 2 day or 3 days on flow based composite basis. So accordingly we have to see, then we have to make the inventories. So inventorize the human activities in the upstream catchment area of the water body to identify the non-point source of pollution. So the pollution source, once we identify, we have to identify whether it is point source or it is non-point source of pollution, and then again we have to continuously monitor and take samples and then look say from where it is coming from and how the movement is taking place, so that we can go for various measures. And then next one is step number 5, the water quantity information. So, these issues we have already discussed earlier. So, in case of river or stream, we have to acquire the flow data from various government sources and then see how the system is say the source of water. In case of lakes and reservoirs, we have to collect the information on water levels of at least 5 to 10 years, then carry out mass balance, then estimate the least dilution available in last 5 years, then assess the assimilation capacity by applying simple Streeter-Phelps equations, say for example dissolved oxygen is concerned. Then this exercise would give precisely how much pollution load needs to be reduced. Then say in case of river or stream, we had to acquire the flow data, and then in case of lakes we get the data, and then step number 6 is selection of say technology. So, what kind of technologies we had to choose to reduce the pollution or to say improve the water quality. So, here the adoption of simple technology for sewage treatment, so mainly the wastewater treatment is concerned, how to treat the sewage. Then a treatment scheme based on a series of waste stabilization ponds technology, and we have to look for most economical ones. Then multiple stage ponds, say with say for example at least 3 ponds, with the first pond as anaerobic and one is the most widely used and suitable configuration, and then use of low volume flushing tanks will help in reducing the wastewater volume and thereby cost of sewage and then sewage treatment. So, like that we have to select these specified technology. So, some of the cost effective and environmental compatible treatment options can be like land treatment, waste stabilization ponds, constructed wetlands, duckweed ponds, aerated lagoon, rotating biological contractors, upflow anaerobic sludge blanket systems, root zone treatment, like that. So, accordingly the suitable technology we can choose for the specified case, and then we can reduce the pollutant load coming to the system. And step number 7 is financing the waste management. So, we have to see how much money is available, how we can economically do the things. So, in India with fast urbanization, wastewater quantity is approximately about 13,000 million liters per day. So, each million liters per day cost about rupees 10 millions for establishing the treatment facilities and about 40 millions for collection facilities. Then operational maintenance may vary about 10% of the above cost. The major part of the cost on waste management should be borne by urban population according to the polluter pay principle. So, now most of the environmental guidelines or water quality guidelines we stick into polluter pay principle. So, accordingly we have to see the financing of the water quality or waste management is concerned. So, polluter pay principle has 2 benefits. It reduces waste and treatment and can provide source of revenue for financing wastewater treatment investment. So, like that we can look into the financing waste management. Then pricing and demand management is concerned, we have to see that important instruments for encouraging efficient domestic and industrial water use practice are maintained, and then we can induce urban organization to adopt water saving technologies including water recycling and reuse. So, these are the 2 keywords like recycling and reuse. Then demand management programs like promotion and distribution or sale of water saving devices. Then the waste management benefits, say like the benefits will be for local citizens, protection of environment, protection of public health, protection of water resources, then water supply, like that. Then step number 8, maintenance of sewage treatment plants. So, say we have to see that regular analysis of operational parameters are done, so that we keep the strict maintenance of the treatment plants. Then persons should have adequate knowledge, and we have to train to operate the sewage treatment plants. and then there should be provision of auxiliary power backup, then proper maintenance of the sewage system, namely sewers, rising mains, intermediate pumping stations, then resource recovery by way of raising the revenue through sale of treated effluent for irrigation. So, like that we can see that the we have to maintain the sewage treatment plants appropriately. So, that is about the step number 8 when we prepare the guidelines. And step number 9 is pollution from industrial sources. So, pollution, say generally industrial sources are concerned, we can control the pollution at source itself through various treatment procedure. So, the water polluting industries which had not so far installed environment treatment, effluent treatment plants should be asked to furnish a time bound program for treatment of their effluents. So, this we have to put it in the guidelines and then strictly implement. Then emerging technologies such as aerobic composting, vermiculture, irrigation, etc., and then secondary treatment, all the secondary treatment like using the wastewater for irrigation purpose or vermiculture should be adopted for the organic waste. Then root zone technology is also being advocated for energy saving for treatment of industrial wastewater. And then incentives we have to give for the industry which go for appropriate pollution control measures. So, that is also important. Then reuse and recycling, we have to say now the main motto is zero waste discharge. So, that is our the motto of most of the industries. So, that we can achieve through reuse and recycling of the industrial wastewaters. The reuse and recycling of waste for agricultural purposes help to reduce the pollution, reduces the requirement of fresh water for use and supplement the much needed nutrients. Then waste minimization and clean technologies like recycling techniques, which this recycling and reuse will be discussing later in another module. Somewhat more details will be discussed. Then waste strength reductions, then wastewater discharge standards and charges on residual pollution. So, like that we can look into. Then 10th step is pollution from non-point sources. So, another important source of pollution is non-point source. So, this is extremely important to focus attention upon the problem of non-point pollution from like unsewed sanitation, uncollected waste dumped haphazardly in urban and industrial areas, and application of chemicals in agriculture such as pesticides, insecticides and chemical fertilizers. Then presence of unacceptable high levels of the persistent pollutants in groundwater or surface water. Then the pest management is concerned. Integrated pest management policy we can evolve so that say we can use very less pesticides for the control of the pests. Then the last one is other important options for water quality management include say as we discussed the reuse and recycling of treated domestic sewage. So, these issues we will be discussing later in a later module. Then encourage participatory approach with involvement of all relevant stakeholders. Then balance economic and regulatory instruments. Then prevent pollution rather than control. So, the main motto should be we have to reduce or we have to prevent the pollution or the say when we deal with water quality management, our environmental guidelines or water quality guidelines, the main motto is prevent the pollution than the controlling. So, say once polluted to remediation or that is very difficult. So, first we have to prevent the pollution to the environment, either to the land or to the aquatic systems or to the soil. Then say we have to have very strict rules and regulations or guidelines we have to set up, and then these environmental guidelines should be strictly implemented through various monitoring or the say the bodies like Central Pollution Control Board or State Pollution Control Board should take appropriate actions to implement these guidelines very strictly. So, some of the references used for today's lecture mainly from say Central Pollution Control Board websites and then EPA website. Then a few questions, say for tutorial questions, critically study the environmental guidelines for water quality management for India and compare with the standards of USA. So these details are available in the website. So study this and compare. To study the various measures that can be adopted to improve the water quality management guidelines, say for example India. So what is there you study and then compare and how we can improve. Then a few self evaluations or assignment questions, illustrate the importance of watershed based water quality management. Then what are the important goals of water quality guidelines, discuss on water quality monitoring protocol, frequency and parameters for surface water and groundwater. And then what are the important features of environmental water quality, discuss on the important steps to be followed in water quality management as per Central Pollution Control Board norms, illustrate the selection of technologies for wastewater management. So, all these details we can you can get from today's lecture or through the various sources as I mentioned. So, with this the module on water quality management is over. So, we discussed the issues related to water quality management in 4 lectures. So, now we will be going to the next module. So, thank you.